So, can you hear me? Thanks for coming to this meetup. It's about Pentaho Bay Area Meetup. But this event has been promotion in 3 different meetup groups. One is Pentaho Bay Area Meetup. The next one is Palo Alto Data Science Association. The last one is Silicon Valley Financial Services Cloud. And today we have a raffle. So if you forgot to put in your business card into the raffle box, please make sure that you are in if you want to raffle. We have a Hitachi branded speaker. It's a Bluetooth and it's battery powered, so you will love it. And the next thing is, so we have a speaker, Jeff. He's been a PDI user for 10 years, and previously he worked for LinkedIn and Google, like Pentaho Data Integration Architect or ETL developer, and he is now working for Bank of New York Mellon as an ETL architect. And today he's going to talk about a Python and R script running on executed from Pentaho. And please welcome Jeff.
Okay. You guys hear me in the back with the speaker? Cool. All right. Thanks for the intro, Hiromu. So, my name is Jeff Lewis. Today we're going to go over how to use the R and Python executor steps in Pentaho data integration. Quick disclaimer. I'm the Pentaho guy, and I was going to have a data science guy standing right here, fielding all these questions about how do you really apply R and Python in daily life. So I'm really amateur when it comes to these things, but I have worked with them in the Pentaho context. So quick show of hands. Raise your hand if you work with R regularly. How about Python? Pandas in Python? All right, cool. All right. So we're all newbies, that's great. So quick introduction to R. That's just the Wikipedia version, but R is a statistical programming language, taking quite a bit of popularity on right now as an alternative to more expensive packages like SAS, while having an open architecture that's producing really powerful libraries. Python Pandas is basically the concept of R written in Python. So where R's greatest strength is to have data frames and be able to quickly process those and have advanced functions with flexible data structures. Pandas provides those same kinds of data structures. PDI is a data integration tool. So Pentaho, which is now part of Hitachi Data Systems, where we stand, was acquired, I'd say around 1.5 years ago. Pentaho provides a full suite of business intelligence and analytics tools. So ETL, Pentaho Data Integration being one part of that. What we're going to cover today is a few lessons learned in setting up the R executor step. Same thing for the Python script. And then we're going to jump into usage of steps with sample iris data. So this iris data is kind of the hello world of these tools. It's used in data science, and it has various attributes around flowers. And then finally, where my expertise shines a little more is we can go over with some a real world scenario where you have to collect and transform data, where you need to filter, where you need to really use the Pentaho core. The idea here is to, with even bothering using these tools, because of course you can do all these transformations in Python itself, is to just make things a little bit easier, make it a little bit more iterative in how you prepare the data. Talking to any data scientist, the first thing they tell me is they spend 90% of their time in data prep. So the idea here is, well, how about we put a more powerful data prep tool in front of that model building. So we'll look at some of those steps there. A little bit about my environment. I'm running on OS X. The Pentaho Data Integration 7.1 was just released on Monday. So I've been pulling down and evaluating the latest build. Inside that, I'm running the Python Script Executor. That was pulled down from the plugins marketplace inside the tool. And then the R Script Executor came packaged with the 7.1 Enterprise Edition. Now these steps actually, part of their power is they're not embedding a certain version of R or Python. Instead, they're just extending the tool where they're using the core binaries of your system. So I've installed latest and greatest Anacondas, which is Python 3.5. And then I have installed R33, which is the latest build there. So these tools are going to be using the C-based binaries of those executables. All right, going to jump into the demo. So, as I said, a little bit about my environment. If you're not familiar, I didn't have a show of hands. Who's used this before? Okay, cool. So this is the graphical environment of Pentaho Data Integration. It's called Spoon. It's called Spoon because the command line tool is called Kitchen and the web server is called Cart. It's like a kitchen thing. So this tool, this GUI, is used to design, graphically design, extract, transform, and load workflows or data integration workflows. So the code that we're looking at here is first using the R Script Executor. So what the code looks like, or how it was constructed, was we worked through, back up, and we drag and drop a step onto the canvas. Now, this step allows you to process an inbound set of rows, so you can prepare it in a stream of data using the Pentaho tool. You can also, it'll run any R script or Python script you might want. These are actually it's the same code base that runs these steps. So if you had flat file data, you wanted to load it straight into R, you could use that as well. So you can pretty much run any R script you might want. The big thing is that you have to be conscious of how you are interacting with your data frames. So this script in particular is loading the iris data. It's built in as a package into R. It is grabbing out of there, grabbing a subset of that data, and it's performing PCA analysis, which is a way of taking dependent variables and decoupling them. So basically making independent features that can then be analyzed. That's as good as I can explain because I'm not a data scientist, but I've been trying to learn. So this PCA analysis, move the step I put out there. So this is going to run sample data out of memory and then output it into a data frame, which is really just a table for our purposes. The big thing that makes a data frame special is it's a table that's multidimensional, so you can have multiple attributes pivoted into that table. So it's very flexible. So in my Spoon environment, I can click on the R Script Executor, and I can see what the PCA analysis produced here, which is a bunch of these individualized features, independent features that could be used for other forms of analysis. So there's a series of these scripts, and to look at, that just loaded it right out of the step, so it didn't actually have input from the tool. This next example actually takes the CSV input. So there we point to a flat file here. We parse that data, So we have basically a file of integers. You can see what the source data looks like by going here. This data set actually didn't look into what it does. And we can see a little bit more about how the workflows really go. So you have a box to determine number of rows to process. This is set to all. So let's say you have 5 million rows of data. Well, that's going to stream everything that you have in your ETL transformation into a 5 million row buffer, and then it'll send it into the binary of R. And then it'll execute your R script using the R binary. If you, alternatively, you can set to row by row, and it will reservoir sample. So you could say in your 5 million rows, I only want to run the script 1 row at a time, and I want to run it with a certain random seed with a certain row set. So that's where you can set the size parameter here. And then finally, you can set batches. So in that 5 million rows, you could say, I want to run batches of 50,000, and that should fill up a buffer 50,000, run the script, output, and then go like that. So really how it's working is this transformation, in a blank transformation, you would go to the step name that precedes it. You have this list here because you can make any number of data frames as inputs. So, and then name what they are, and then, so that's where we would name it. And that's how it's going to be attached to the script there, is the name frame1 is how that data is loaded into the R script. So you'll see here that you initialize the frame1, and then a subset function takes frame1, and I believe this is a filtering parameter, where it's saying select equals class. So creating the DF data frame here. And then, much like our previous example, the PCA analysis is executed, and then is loaded into another data frame called DF2. And then the output fields are indicated here. So the step will basically analyze the script and let you take the relevant output. So I can clear this out. And it'll read the script and figure out what the output fields are. So then running that, similar function. Go to preview. Here's our raw data, set of integers. Here's our PCA analysis after execution. In Pentaho, the dummy is just a flow-through step. So it's a great place to do a preview, as opposed to writing a CSV out or something like that when you're just testing. Finally, this last short example with R is going to show using multiple data frames. So it's actually 2 copies of the same data set. This one is linked to frame 1. This second copy down at the bottom is linked to frame 2. And this uses a function called rbind to merge these 2 frames together. So then, when they're put together, output looks like this. There we go. Okay. So that's the R executor. Do you have any questions? Before I keep going? Go ahead.
In the second example, so if you could go back there, so how did you pre-execute the flow and then get your output pre-populated there?
So in the second example, when you define your R script, and then there is an output there that deleted and then it grabbed it again. So it grabbed it from the script.
Yeah.
So it read the script and then it knows the output's going to be those 16 values.
Yeah, because it looks at the object
16
properties.
attributes actually.
Yeah, basically runs the script and figures out what that output data frame, what the metadata of that will be.
Is it an add or a join on the data? Is it merging it together?
It's
Or is it
replacing
just an
the
add
data.
at the end of it?
It's replacing the input data set. So a data frame being a table, multidimensional table, it's running whatever's in the R script, and it allows for one output data frame, that being an output table. So whatever the properties of the output are, that's what we're seeing. So in this case, it's a statistical algorithm that's used to prepare data based on dependent attributes. So it's basically a score, so it's a set of scores for each column. So replacing the input data, which was simply raw data.
Is it adding it to itself or is it merging it to itself?
In this case, you're not appending new data to a string, like you often would in ETL workflow. The data is simply being sent into effectively a black box of a script, and reading the output is the next step. So it's whatever the R script whatever the R script processes the data, is what you'll see as the output.
Okay, I can't, I guess you're not getting what I'm asking.
Okay. All right, so I'll move on. Sorry I'm not quite clear on your question. Maybe we can take it offline.
Can I ask one additional question? So let's say if we handle a problem where the input is not a data frame,
Yes.
but instead images or other data formats.
Yes.
So what would be a good workaround to make those cases work?
I would say you can have, for one, you could go more like this model, because you don't have to pass data through Pentaho to use it. It can be the starting point. So as you see, there's no input to this one. So if you needed, you just use the native R function to say load this image. The other thing you can do is you could probably use a binary data, like you could read the data in potentially a string, or I think if you tweaked it a little bit, you could pass in the raw binary data of the images you want as a column, and then feed that.
Okay, thank you.
Yeah. All right. So, moving along to the Python side. So, this really does work a lot like the R side does. It's a similar library. I personally am a little more interested in learning Python and Pandas because of the extensive libraries, and I'm more comfortable with Python as a language. So I have a little more fun playing with this. So this example, I'll hit the run button first. By the way, this transformation is constructed where you have one input and then that input is copied 4 times. That's where you see the different hops, and there's a copy symbol on the different hops. So the first example is doing quartile analysis on the same iris data set that we have in the R executor. And so you'll see that this first tab of configure looks pretty much identical to the R Script Executor. So you have a choice on the number of rows you want to process, same options, whether you want row by row, reservoir sampling, and batches. And then you indicate which step name is going to be the input, and then you name the data frame, and then you have your Python script here. So you do run an import statement here, and then a quantile function, which is going to be built into the data frame library of Pandas in Python, is executed here. And then the implicitly creating a new data frame called quant. So in this case being a two-dimensional table. In this step, you indicate which Python variable you want to get. That means what is my output going to be out of all the things in this script? What does the tool need to look at for the output? And then over here on the output tab, well, I'm going to hit get frame fields, and that's going to do the same thing that it did in R, which is look at that output frame and get the object properties to get the column names and the data types. So the output of this step looks like this. This does the same thing with the PCA function in Python. So data prep there. This is an interesting one in that the output that it's writing is using a visualization library. So it's actually outputting, I believe, SVG graphic instructions. But it's something that can be read in the R graphing library or graphing tools. So the output comes out as serializable, so it's just binary information that's read downstream. That is then used, so then they take that serializable information and they make a set of PNGs with it. So right here, so they're taking in, I don't know if there's much into this, but yeah, basically saving out the graph files to disk. Okay, and then the final example that comes with CPython is pretty involved flow. From my understanding of this example, it's taking that same iris data, using some additional libraries, and I think the goal, the intent of this example is to actually show processing with one step and moving it into the next step. Beyond that, I can't really flesh it out. All right. What do we think about the Python? Pretty cool, huh? All right. Questions?
So, does this framework at any point allow some user interaction? Let's say in your PCA case that you just mentioned, which is a very good example, by the way. Let's say if the user needs to choose some additional operations on the PCA, like specify some of the columns or rows that you want to eliminate, and we wanted to enable those interactions from the user. What would be a good way to do that?
Well, you know, I think in that case, if you just want to select, if everything flows through in this data frame concept, like what I would do as a Pentaho developer, to skip towards what I was going to work on next, is because I didn't do a lot of data science, but I did a lot of data prep in like preparing for this talk. And so basically you can prepare the column set. So I built out a bunch of columns to, you know, do some calculations, and I split out, I pulled the year, date, and month, I extracted dates out to make separate columns for them, and things like that. And I also did an analytic, I did a window function. And so I used all that, and I constructed the data frame that I thought I would need using a select value step, which is one of its primary functions is to filter down the columns that are needed. So.
Okay, so let me try to understand this. So essentially, this data is one flow, right? One pass from the point that it is prepared to final writing out the output. So there's not an effective way of.
There's not an effective way of, allowing the user to make an arbitrary interaction of this flow.
Yeah.
Okay.
I think the use case here is you get the iterative feedback because you can click on each step in the data preparation phase. And then your R in Python is a little bit de-emphasized, it's a little bit less important that you do all your cleansing inside the script, and that perhaps your actual algorithms can be a little bit more simplified.
I see, that's very helpful. Thank you.
Yeah, thanks. I think the other thing that gets pretty interesting about this is that you have a lot of options on how you want to send the data back out. So if you want to share the data to a database, if you want to push it out to CSV, you can basically connect to any database. You can easily connect it to Hadoop. You can push data into Hive. So really, however you want your overall life cycle of the data to be, this simplifies it quite a bit. So, so this was basically what I worked on today. We're going to go ahead and start a quick workflow to kind of get to the same places. So I work for a bank, and some of the stuff we've worked on involves our tech data, which means exchange rates. And so I pulled down the January tick data for the Great British Pound to US dollar conversions, which is about, for the month of January, was about 40 million rows. So a decent sized data set. Especially since we're new to Pentaho, we'll make sure we go through some of these basics here. So I opened up a new transformation. I went into my input steps here and grabbed the CSV file input step. I double clicked to go into the configuration for this step. To find my sample file, I'm going to hit browse on file name, go to data. Here is the folder that contains my data. Now, I know that I have commas for a delimiter. Let me change that otherwise. And I know I don't have a header. So, quick way to look at this. So there's my first 10 rows. So from having previously configured this, I know that this first column is a type column. It's indicating the type of transaction. I'm going to hit down, and I'm going to say the timestamp for this transaction is this next column. And then the price is going to be, I believe it is indicating the from price and the to price. Now, looking at the format here, I'm going to use this standard file formatting. I've got a list of formats I can drop down here. I can see that I go year first, then month, then day, and that I have hours, minutes, seconds, and milliseconds. So this is the right pattern here. However, I don't have slashes. So I'm going to remove these slashes from my format and hit enter. And then I can see that I have numeric data, and I will pick a format string that doesn't hide my decimals, which is just something like this. Okay. So what I've done here is I've actually read the CSV data, I've parsed it to these data types, and now I have timestamps and numeric data to work with. Okay, so the first thing I'll want to do, because I already know I have 40 million rows, is, well, let's do a quick test and see how fast it runs through memory. It's always kind of neat to see. hit run, hit the run button, I can see my step metrics down here, and I can see that without doing anything to it, I actually get pretty good throughput. I simply read all that data, the 43 million rows, in about 3 seconds. Now I don't want to use that, I want to do something else. So I'm going to disable that hop just by single clicking it. So you can kind of make different trees of stuff, and that's the effectively commenting the next step that you're trying to run. So the next rule I need to apply here is I don't want to run all 40 million rows. So I'm going to make a row number column, which is just a feature as part of the step, so it's going to make an integer value telling me what the row number is. And then I'm going to use the filter step. You might notice there's so many steps, but there's a search box, so I tend to search for what I need and then pull it out again. So I'm going to hold shift between these two steps and drag my mouse to make an arrow. We call that a hop that connects the two things and creates a data flow. Then inside here, I have a means of making different filter criteria. I can actually add, any number of filter criteria with ands and ors and all those kinds of things. So I want to filter down to, let's just use 1 million rows. 1 0 0 0 0 0 0. Now, the next thing I'm going to need to do, from what I know of this data, is I actually need to average these two columns together. So the before and after, typically when you work with this data, you would just average the two together and throw out the individual two columns. So I'm going to use the formula step. Nice thing about the formula step, it performs pretty well. And you get some convenience of, it's a very Excel type syntax. So I know that my column names are here. So I want to take the from price, plus the to price, put it in parentheses, divided by 2. Now my new field, I'll just call mean. I do need to indicate a value type, which would be numeric. And I'll hit OK. So now I'm going to hit run. If I go to my step metrics, I can see that I'm reading all the data, but I'm only writing 1 million rows forward. And that in my formula here, go to the preview tab, there's my mean for my values. Okay. So now the next thing to look at is when, in talking to my colleague in data science who worked on this data set internally, is that most importantly we need to analyze the difference between the previous trade or the previous tick. So we need to do a window function giving us the previous row's values. So in Pentaho we have what's called the analytic query. Set this up. So I'm going to make a new field called mean lag 1 against my mean column. And I'm going to say I'm going to lag 1 row backward to get the subject here. Hit run. Okay, so there's my lag 1. Now, now then where I went with this is I can go with I made another formula, another delta. These two things. So here in the formula I can say, here's the difference of these. Square brackets, same mean. Minus multiply 1. There we go, we'll get the delta there. Okay. So you could continue with these kind of data prep exercises. We have grouping functions, so if you need to take an overall sum of the row set or an average or anything like that, that would be available to you. But for my purposes, I just wanted to walk through like actually loading it into a Python data frame. So the next thing that I did was I prepared the data frame structure that I needed. So I no longer need the row number field or the from or to price. So I'm going to remove those and we'll rename this from price, I think. Actually, this is to price. Because this is the current price of that row, and this would be the from price. And then, to be honest, we don't need that one. Okay? So then I can take the R executor. Sorry, I'm going to take the Python. So we'll more comfortable with that. Go in here. I have those same options. And some of this stuff that I'm doing in the tool, you have the flexibility to do inside the step. So if you wanted to just take a certain batch of rows, you have that feature here with the size parameter. So I'm going to indicate that I have a select values, and then let's just call our frame name frame 1. And then I believe I can get away with just doing this, which would be just passing the one data frame into another, outputting it. Okay. So we basically, for each row, for the whole data set, we passed it from one frame into another. So you could put any kind of Python code you want in the middle. It actually isn't restricted to using the pandas library. That's just how the data structures have to be. So you can do pretty flexible things with it. And finish this out, make sure everything runs. Script is still running. Million rows may have been a little high. I haven't tuned the memory on my Java environment here. Ta-da! All right. I actually loaded all 43 million rows into a data frame, and then my Java heap crashed, and I made the whole thing really bad. So I. Word to the wise there. So this output's actually coming out of the Python executor. So the convenience of this step means that now when it's time to output my work, I have the ability to take, I can push it out to JSON, Nice thing about Pentaho actually is if you wanted to make a web service with something, you can check the pass output to servlet feature, and then when it runs on the web server, you can execute it and it'll run this transformation and publish that to via servlet. So then you've got stuff for databases and big data systems, wherever you might like. We'll just dump it out to CSV there. Okay.
I have a question.
Sure.
So you mentioned that in a JSON output, you can enable the servlet option.
Yes.
In order to make it as a web API endpoint, I think you have to deploy this transformation file into Karte or Pentaho Bay server. Is that right?
No, actually, so long as it's on, there, you can reference a file name to execute on cart. So that means, so long as the file is somewhere on your system, you can make the web service call to execute that transformation. So it doesn't have to be in a repository or registered or anything like that.
My question is because you are running this Spoon on your laptop, but in a practical use case is that you want to deploy this transformation file into server and server runs Karte on it
Yeah.
and make it as a web server and web API endpoint so that when client access this web API endpoint, that gives you a JSON output. Is that right?
That's right.
Oh, thank you.
Yeah.
Jeff, I have a question. You have taken the data from the British pounds exchange rate. So
So from the exchange rate data that you gathered, what are you trying to analyze out of it?
Well,
You're making predictions that it will go up or it
basically, what the true data scientists working on this project was doing was looking for predictive models. So they actually provided me with a little bit more complex R script that that builds a predictive model over the exchange data.
Okay. Is it being used in production at any point in BNY?
No. So it's something that's been looked at. Yeah.
Hey, so I look at the workflow, it all makes sense. My question will be, so what will be some significant advantage you think about this workflow compared to if I just build a program and do this mathematics?
Well, I think what we think of this as is you've got something that's self-documenting, it's graphical. You might be able to have a lesser skilled resource do the preparation for the more expensive data science resources. And then we feel like over time, in some cases, you should be able to kind of capture this code, put it into production, or just put it into kind of an intermediate state. But it just becomes a little bit more shareable because in a given Python workflow, you could go about problems in any number of ways.
So because I personally use Spoon myself as well, I know one thing is this tool is actually pretty heavy along with Anaconda. So just curious, so again, like compare if someone say a lightweight program, and he can do the same thing, and this thing, yeah, it provides more graphical, it's more easier to share. But what would be like, is it better in handling a large amount of data or?
I would say so. The thing about writing your own Python is the fact that this is a streaming tool means that you can run millions of rows without it breaking. And when you're running your own Python stuff, yeah, there's going to be libraries to do streaming with, but you're not going to get the convenience of how this works because you pretty much hit the run button here and it takes care of all the buffering for you. It's basically passing one 10,000 row buffer between each step all in parallel, and then it's managing itself kind of like a database query. So so basically it just works, as opposed to the memory issues you might see when you really load large amounts of data.
Okay, cool.
No problem. One other thing to add here is that because you get so many, because it's JDBC ready, you drop a jar file in, and whatever database you need to load to or read from, that's there. So yeah, it's definitely a heavier tool, but I mean, I've seen the Python-based workflows, and I think it's pretty simple to start with, and then when it comes time to really do something with it, it gets bigger and bigger and bigger until it's, you know, similar in function. So. Anyone else have questions? Comments? I guess let's shut it down, guys. I can keep talking.
I have questions. I set up the Python environment on my laptop,
Yeah.
and it was hard to set up the appropriate Python environment for Python Executor. Was it hard for you to set up the Python environment?
Yes. And mainly because OS X comes with its own distribution, and I got it through Homebrew, and then I tried it through native installation. What I ended up settling on, having all these different binaries and packages and paths, was to use the Anacondas package and the latest version of that, and I just let it install everything. So I wasn't missing a library when it was time to run. And that got me, I didn't have any problems after that, so that was one thing I wanted to put in there on my lessons learned here. As well as I had the same problems with conflicting environments with my R environment. So I had installed a GUI a long time ago, which had its own environment, and then I installed a command line environment, and I had different library folders. So part of your setup with, you don't need to do much environment setup for the Python side, because all it's doing is calling Python binary. With R, I needed to have a environment variable set for where the library was. So I got that wrong, which caused problems in using the R setup.
And where do you set up that? So do you set up that inside the spoon?
Yeah.
Or
Okay.
can you show that?
Yeah,
Can you
sure.
show us that?
Yeah, sure. So I'll go here. And then, so this is what the variables look like. By the way, I'll post this presentation, and it's got links to the tutorials for you to reference. So you can get the sample data, you can get the installation instructions through those. So you have to set an R home, and you have to set a libs user. So luckily, both of those are short commands in your R environment. So I forget the command, but you type that, it's going to return the environment variable.
Okay.
However, I returned the wrong environment variable because I pulled it out of the GUI. So that was an issue for me.
And
For the Python, so you don't need to do anything. You just install Anaconda, and then how do you link that to the Spoon environment?
So long as you've got the right, it has to be the Python when you hit the path. So you have to let Anacondas take over.
Okay.
He has his own Python too, so.
Yeah. So the built-in OS X one will not work well.
Okay.
So there is a bit, but as long as from what I saw, so long as I went straight with Anacondas and I removed my other stuff, it started working pretty well. And also, even though it says on the tutorial that 2.7 is okay, and I found that it's not. It has to be 3.3 or above. And that's what first got me, actually. So, and it comes down to these steps have been around a while. Some of these tutorials are to like version 5, and there were some big changes to 5 in later versions. So I think it's all 3.5 or 3.3.
So, an additional. Is it working? An additional question. So from your last slide, you said avoid loading. Don't load too much into a data frame.
Mm-hmm.
So what if you need to do that? Are there any? If you have any experience trying to load, create big data frames or something like that?
I think I need a little more time to test what happened when it broke today. But I know that I had a default memory footprint in this Pentaho environment. And while I have this up, I can probably tell you how many gigs of memory. The environment will work well if you crank it up to about 4 gigs of memory. I don't think that, if it was a Pentaho problem, I don't think that 43 million rows would have been a problem with that much memory. But I would say that you might just hit limitations of the system based on what you're trying to do. So whether it was Python that was mad because I loaded 43 million rows into one data structure, or whether it was Pentaho, I think it just kind of takes iterative tuning.
Any other questions or comments? Then, thank you, Jeff. And we're gonna have, do you wanna have something?
Well, before we all break today, and hopefully people who are new to Pentaho have enjoyed the talk, I'd like to elicit some feedback about what you guys might be interested in for future meetups, and whether you thought this was valuable. So we could have that offline or in a group, I don't care.
Do you have any feedbacks, comments, or what topics you are interested in most?
I think it makes sense to target applications. Are you trying to address the financial services data, or are you trying to address retail data, such as people from Target and Walmart, right?
Yeah.
I think different sectors and application scenarios to be able to share how data scientists has tackled all these problems, right? And it will be good knowledge sharing among the data scientists. That's how I felt. It's good to know some of these tools.
Yeah.
Yeah.
Yeah. The practical application of what we're going to do. Yeah. That's good feedback. Thank you.
Yeah, I agree with you. So we are at Hitachi, and I'm from Hitachi America R&D, where we have many different laboratories inside, and we have big data lab, and there are many data scientists. Maybe in the next future meetup event, we will invite those data scientists to give a talk about their data science on practical, real data sets. Could be more interesting for you guys. Okay.
Thanks for the feedback.
Yeah. We're gonna have a raffle, right? Kaneko-san?
Okay.
So can you pick up? Can you mix it up so that not just the last person who put it could be chosen? Give a chance to the first person to come here, right?
Okay. Okay, so. Oh. How can I read?
It's not yours, right?
Richard
Vargas?
Oh yeah.
Who has come here for first person to come here,
Yeah.
right?
Yeah. Congratulations.
Congratulations. And we will close this event, but we have time before the door closed. So if you want to talk to like presenter or talk to each other audiences, please feel free to do so. Thank you. Thank you for coming today.